Welcome to another NUCIDA training session. Today, I would like to talk about waiting and synchronization in TestComplete. If you like, please give this video a thumbs up. Subscribe this channel and click on the bell to never forget our upcoming sessions. We are creating reproducible steps as the reflection of a functional user, but through automation this will happen as quickly as possible. While going back to the original question of why we create automation tests, some might instantly think of speed. Yet, this perception is somewhat misleading. It's not entirely accurate. Speed is a byproduct of having automation tests. In actuality, the real value of automation lies in efficiency. This describes a significant shift in our workload. Frequently, manual testers find themselves engaged in evaluating repetitive happy paths or standard trajectories. Testers either prefer to abstain from such routines or want to spend their time on more valuable tasks. That's why we bring in automation for efficiency. For that efficiency to be truly valuable, there's a trade-off at times between speed and stability. On one hand, stability is critical for automation tests, more so than any form of speed. However, on the other hand, automation tests, when they are stable, will always be faster and more efficient than a manual flow. So the golden egg, as one may say, are the short stable tests that you don't need to worry about. You can build that into your testing, for example in TestComplete. However, for that you must have a good understanding of how to handle timing, or what we call synchronization and optimization. Synchronization challenges, often synonymous with being in the wrong place at the wrong time, frequently at the surface. Most commonly you're waiting for a page to load in web objects or waiting for the next screen to appear in a desktop application. In other cases you may be having a delay of some kind before an operation. OCR operations often require a delay before activation, which is a common occurrence. We influence this by using two types of waits and different frameworks. Specifically, in TestComplete language we call these static waits, which is a delay operation involving a fixed amount of time in milliseconds. This delay is inserted into a keyword test or script, allowing automation to synchronize with the application. Alternatively, we can also use more clever and efficient dynamic waits. The project comes with built-in auto waits, set at 10 seconds by default. These timings can be customized on a per-operation or project-wide basis. Additional wait methods are available, such as wait property or wait child. These methods allow us to wait for specific element properties to align, enabling seamless automation. An example for such a specific element could be something like having an enabled property equal to true or false. Mostly, we choose it to equal to true. In other words, we're saying that we don't want to do anything until that element has that property equal to the true value. For scripting enthusiasts, control flow operations like if object can be utilized. Distinct from a traditional if statement, this construct involves conditional flows that await the presence of specific on-screen elements. When the designated element is recognized, predefined actions are executed. A practical illustration is the familiar login screen scenario, featuring elements such as the login button. Imagine loading a browser and navigating to a designated URL. In this context, I've introduced a wait element method. Here, the method hinges on a selector, like the next half selector in this case. The essence of this control flow lies in patiently waiting for the element to consistently appear on screen. Additionally, you can include an on-screen action within the keyword test, simply direct it to the relevant part of the screen, or even a specific element. This streamlined approach ensures synchronization with the screen's dynamics. For instance, when pointing at a specific element, a red box will appear around it. Furthermore, on the next screen where we see all our methods, we can search for a wait method and see the various ones. The one I've previously introduced is the wait element, and it's worth noting that wait property is another alternative available. As an illustration, let's consider the login button. Alternatively, we might focus on the login email field. By applying the wait property method, we can specify that the field should possess an enabled property, if accessible. This property must either be enabled or set to true. This method represents one approach to waiting, entailing a form of control flow. Moreover, there's another avenue, wait child. Here, given its placement on a specific page area, we're capable of awaiting a designated child element's appearance on the screen. Transitioning to the subsequent screen, our focus shifts to identifying a specific child element. This could be an XPath expression like the one demonstrated here. The ensuing task involves waiting for a designated duration, such as 0 seconds. Nonetheless, this timing can be manipulated using a millisecond value, like 3000 milliseconds. These instances highlight dynamic wait methods, including the standard built-in auto waits. To elaborate further, consider accessing Tools, then navigating to Project Properties and Playback Settings. Here, adjustments to runtime settings enable the manipulation of auto wait timeouts and delays. The previously mentioned auto wait timeframe was set at 10,000 milliseconds or 10 seconds. It's also possible to introduce distinct delays between operations. This global configuration applies across all actions. Moreover, individual actions can also be influenced. For instance, take my initial operation, where I'm targeting the email field. If I anticipate prolonged loading times or potential obstructions, I can personalize the auto wait timeout for this operation. Through this, we can overwrite the project default to some other value for this individual operation. To explore these options, simply right-click on the top toolbar and select Field Chooser. Adding to this, I'll integrate the Test Timeout element, offering insights into each operation's behavior. For instance, suppose I modify one operation's timeout to 20 seconds, equivalent to 20,000 milliseconds. Consequently, this operation's execution time doubles, serving as an upper ceiling while other actions continue their usual pace. This adjustment is equally manageable within the display view or in scripts. By converting a keyword test into a script, we're granted greater control over individual operation timeouts. This point in the script allows us to define session-specific options. Subsequently, at line 8, we can revert to the prior configuration for another operation. These mechanisms encapsulate the concept of waits, exemplifying their practical application. I encourage you to delve into these functionalities. You'll find comprehensive information by searching for wait-related documentation. Their utility lies in controlling the flow of operations. In script contexts, you can also delve into exception handling, a topic to explore in the upcoming scripting section. Within keyword tests, the scope extends beyond the surface. Here, you're empowered to incorporate statements like ifs, loops, try, catch, finally, and groups. These can seamlessly be integrated into your keyword tests through a simple drag-and-drop action. Furthermore, there often is a question regarding a wait property, or in other words, how frequently does this property check its designated element? Is this frequency adjustable? Considering the frequency at which the user interface is polled, the exact rate is somewhat uncertain. While not explicitly known, this polling occurs at a notably high rate. This rapidity is attributed to the finely tuned wait, usually specified in milliseconds. Consequently, this approach delves into an extremely granular level, a distinct departure from waiting intervals of seconds. This emphasis on milliseconds rather than seconds enhances the precision of the operation. Furthermore, the significance of time being configured in the project options should also be highlighted. To reiterate, it's valuable to have a strong grasp of these nuances. Navigating to the Tools section and selecting Current Project Properties unveils a comprehensive menu. Within the Playback category, playback sessions are at your disposal. These sections are pivotal, offering valuable insights and options to explore. The runtime sessions here show the timeout values but also error handling. The very starting point of error handling takes place when there is an error, an object recognition error. This stands distinct from common errors or warnings. Here, you're empowered to steer the trajectory by selecting from options such as continuing with the project, halting the ongoing task, or pausing the entire project. This capability extends to shaping these overarching values. Additionally, you can also affect what happens when there's an unexpected window or an overlapping window. TestComplete automatically takes charge when spotting an unexpected window. The system may engage tactics like triggering an escape, inputting an enter command, or clicking a control to regain focus. Examples like these highlight your capacity to influence these maneuvers as well. Whereas, in the case of an overlapping window, you could opt to dismiss it. Although it might not be considered good practice to ignore it, the option exists. The decision rests on your deep understanding of your application. No one comprehends it better than you. These configurations operate at the project level, allowing you to customize them to suit diverse project requirements. Moving on, we'll jump further to 2 waits. The time that we're looking at here is where troubleshooting becomes a concern. It's essential to begin by scrutinizing your logs. If this fails to pinpoint the issue, it might be beneficial to focus on synchronization and timing aspects. However, if this, too, fails to yield insights, considering aspects of object recognition is a logical step. I hope you find this training session very useful. If you like, please give this video a thumbs up. Subscribe this channel and click on the bell to never forget our upcoming sessions. Happy testing and see you next time.